So today we're going to talk about solving quadratic equations by taking a square root. Quadratic equations, remember, are the ones that you have like anything that's like a variable and it has it squared. Okay? So y equals x squared. This is quadratic, okay? And it looks like a U. Opens up or down. And yesterday we talked about the standard form of quadratic when we were like on a graphing calculator like Desmos, right? What did A do? What did A do to our graph? It widens it or makes it narrow, depending how far it is from 0. And then when it gets negative, what happens to the graph? It gets smaller. No, opens down. Okay, flips down, right? And the farther it gets from 0, as it goes down like -10 or -100, it gets even more narrow. Okay. What does B do to our graph? It slides it left and right, and then C slides it up and down. Good. Translates it. That's the math word. Good. Okay. Thank you. Okay, so today we're going to talk about how to solve them. Sometimes we have to use a different method called taking a square root of both sides, where we don't factor it, we don't break it apart. It's actually a little bit easier because all we have to do is use a little bit of algebraic operations to solve it. Okay, so these are the steps. Isolate the squared variable. Take a square root of both sides. There's going to be two answers when you take a square root. What's the square root of 4? 2. Right? And what else is the square root of 4? -2 also, right? It's because what two numbers multiply to, or what number multiplies to itself, or what number when you multiply it with itself adds up to, or multiplies to 4? It's going to be +2 and -2, right? And then solve each equation, check your work. Okay, I'll do numbers 1 and 2. Okay, solve. So number 1, it says solve, so I'm looking for the letter here. The variable I'm talking about is x, and I'm thinking what's happened to my x here? What's the largest exponent here? Squared, right? So that means it's quadratic, right? So is there an x to the first term here at all in any of my problem here? No, so, but I have a constant. Okay, so there is no x to the first term, so I need to isolate the x variable. The x variable is not isolated. We have -8 being multiplied with it, and then it's squared too, so we have to isolate the squared term. So we're going to do the opposite of multiply by -8, which is divide by -8 on both sides. Okay. -8 divided by -8 is +1. 1 times x squared is going to be x squared. On the right-hand side, we have negative divided by negative, which is going to be positive, right? And then 168 divided by 8, well, this isn't too hard. What's 16 divided by 8? 2. And then what's 8 divided by 8? 1, okay? All right? So, and it's a +21, right? But we don't need to put the positive sign. Now the x squared term is isolated. I can take the opposite of squaring, which is square root. When I take the square root, I'm actually getting two answers, a positive and a negative answer. So I'm actually going to write this down as x equals positive rad 21 and x equals negative rad 21. Okay? And then I think to myself, can I simplify square root of 21? Yes or no? Yeah. Okay, what are the factors of 21? Good. Are those perfect square root? Do they have perfect square roots? No. So that's it. So your answer is x is equal to positive square root of 21 or the negative square root of 21. Okay, you can write your answer like this. Here's an easier way to write your answer. You can just put this plus and minus sign like this together, and just because it's the same answer, but they're opposites. One is positive, one is negative. Does that make sense?
Yeah. Yes.
Cool. All right. Isn't that easy?
Yeah.
Okay, cool. Let me do number 2 for you now. Number 2 is 4r squared plus 4 is equal to -11. Okay, again it says solve, which means I have to figure out what's the value of this letter, r, right? What's the biggest exponent in r, or what's happening to it? Squared. So it's a quadratic. There's two answers I'm looking for. So, but there is an r to the first. So what I'm going to do is now isolate the r squared and move all the constants to the opposite side. So the first thing I do is subtract 4 on both sides. So you have 4r squared is equal to -15. We're going to divide both sides by 4. So we get r squared is equal to -15 over 4. Okay? R squared is isolated now, so I'm going to take the square root of both sides. When I do that, I get square root of r squared becomes r. And then remember, I get two answers. I could even write that now, plus or minus the square root of negative 15 and the square root of 4. What's the square root of 4, everyone? 2. So we get r is equal to plus or minus square root of 2 in the 4 is 2 in the denominator. The numerator, is there a square root of 15? No. How do you take a square root of a negative sign? Remember that from the beginning of the year? I, good. So we could take out an I, and then rad 15 stays on the inside. I can't do anything else. It's rationalized, so we're done. There's two answers, and they're both imaginary answers. Okay? Does that make sense? Cool. All right. So if you're on the video, I'd like you to pause here to write this down. Here are three things that we just talked about from the answers here. They're in green right here. So actually add this also to your notes, these green things, okay? These are three things that we pointed out. Students in back, we're not talking right now. We are still working on the lesson. So solutions can be two opposite solutions, right? Just like Braden said, we had a positive and a negative number, but they were both the same number, except they were opposite, right? 2, they're irrational, right? Did you notice how on the graphs it said like 4.35? Irrational means that like they can't become a fraction. You're not a ratio. So like x equals to plus or minus rad 21. Can we write this as a fraction? No, you can't. If you were to like put this in your calculator to give you this never-ending decimal, so it's irrational. We're all writing these three things down here. Thomas, you too, bud. I just put this up like 10 seconds ago. You're fast. Okay, that's all right. 3. Imaginary solutions. Hey, look, we're seeing imaginary numbers again. Remember that from the beginning of the year? You pointed that out. Awesome. And just put this note, when the lines don't cross, right? When we have a graph and the lines aren't crossing, like a quadratic graph, we're saying there's imaginary solutions. Okay? Awesome. You're doing a really good job. So write that down. Give you another few more seconds. All right, so number 3. Okay? I'll give you a moment to get to write this down into your notebooks. We're all writing down number 3. No Desmos on this, no graphing calculator. This is all on your own on paper and pencil, okay? Okay, so let's work together, talk to your group, talk about a strategy about how you would do this, and then we'll do this one together. What would you do on this one? Okay, so what would we do here, everyone? What should I do first? Good, subtract 10. So I know you're probably ahead of me. I'm subtracting 10 on both sides. You got 5r squared is equal to 180. And then what do I do to both sides? Divide by 5. Good. So r squared is equal to, what's 180 divided by 5, everyone?
36.
36, good. Okay, how do I get r by itself? We have it's being squared. What's the opposite of squaring r? Square rooting r squared. Okay, so we're going to cancel those out. So we get r is equal to plus or minus. What's the square root of 36, everyone? 6, good. That's your answer. 2 answers. 6 and negative 6. Raise your hand if you did that right the first time. Okay, a lot of you did. Right? That was an easy one, right?
Yeah.
Awesome. Let's just talk about the solutions. Are they rational or irrational?
Rational.
How do you know they're rational? Because it's a 6, right? Here's the question. When I ask you if it's rational or not, you need to think, can I make this a fraction? Can I make 6 a fraction? Yeah. How do you write it as a fraction? 6 over 1. Does that make sense? Okay? Good. Are these answers imaginary or are they touching?
Those are touching.
Good, they're touching. Good. Excellent. Good job. You're getting it. I'm going to be asking these every time because I want to make sure you got it. Okay, number 4 then. You could do this on your own. Okay. On this number 4, that's the answer. I got a question for you. Rational or irrational?
Irrational.
Good, rational. How do we know that? It's a fraction. Excellent. Is it real solutions or imaginary solutions?
Real. That's a real
Which one is it? I heard 2 people
I don't see an I there.
talk to your group about why it's not imaginary or why it is real.
There's no I. There's no negative numbers.
Okay, so is it real or imaginary solutions?
It's definitely real.
Okay, good. So does that mean the graphs are touching or they're not
That means
touching?
they're going to be touching.
Good.
Yeah. I know for a fact. I don't either.
Okay. That's funny. Okay, here we go. Thank you. Number 5. Okay, number 5. Here we go. This one's going to be a little bit more challenging. This one's going to be more like number 2. I'll give you a minute. Go. So y'all did it correctly, but y'all got it wrong because you forgot something. Can you have the square root of 3 in the denominator? Are you allowed to do that? No, you can't. So, you all got to this point here. You see that? Good job. Very good. But can you have the square root of 3 here? No. What are we supposed to do? Rationalize it, okay? So please fix it in your notes, right? You have to multiply by rad 3 in the denominator and the numerator. And of course, I can't simplify it.
Why can't you have 3 in it?
Why we can't have a square root sign in the denominator? Remember that from the beginning of the year? Yeah. Well, if you don't, then this is a repetition of that. So, okay. So keep that in mind as you do that. Okay. Okay. Again, question is this rational or irrational? It's a fraction, though. No, it's not because it's imaginary. Is the square root of 87 a perfect square? No. Can we take any perfect squares out of it? No. It is because it has a square root sign that it's going to be irrational. Irrational. Does that make sense? Yeah. Okay, second thing, imaginary or real?
Imaginary.
Good. So what can we assume the graph kind of looks like?
Not touching.
Not touching. Good. It's not touching. Okay. Okay, good. Here we go. Last one, number 6. I'm sure you could do this one perfectly now that you saw number 5. Go. So your answer should be n equals plus or minus I rad 42 over 3.
That is what I got.
Most of you got that. Good job. Whew. Doesn't that feel good? Okay, good. So, again, rational or irrational? I heard 2 answers.
Irrational.
Talk to your group about it. Rational or irrational? Okay, what is it, everyone?
Irrational.
Irrational. It has that square root of 42. It's not a perfect square, so we cannot. It's not going to be rational. Okay, and it's imaginary. So what do we know about this graph? What can we assume?
That they're not touching.
That they're not touching. Good. Good. Okay, that's it. That concludes the lesson here. If you're on the video, I'd also like you to, not this one. If you're on the video, I'd like you to practice these. And then the answers will be coming up. So pause the video here. And here are the answers. That concludes the lesson.